Have you ever dreamt of creating anything you can imagine, from a piece of art to a brand new invention? What if I told you that this dream is now a reality thanks to the groundbreaking technology of OpenAI's Dalle and Jasper? These cutting-edge AI models are revolutionizing the way we think about creativity and innovation. But what exactly are they? And how do they work? In this video, we'll explore the fascinating world of Dalle and Jasper. Enjoy the video. Greetings, tech enthusiasts. I hope you're having a fantastic day, and I'm so excited to bring you the latest and greatest information in the world of technology. You are watching Technologia, where you will have the opportunity to have your questions answered. In this video, we will talk about OpenAI Dalle and Jasper. OpenAI Dalle and Jasper. Dalle is a generative AI model developed by OpenAI. It stands for Deep Artist in Many Little Elements, and it is a 12 billion parameter version of GPT-3. The unique feature of Dalle is its ability to generate high-quality images from textual descriptions. Given a textual description, such as a three-legged elephant holding an ice cream cone, Dalle will generate a corresponding image of the described object. This opens up exciting possibilities for creative applications, such as visual storytelling, product design, and more. Dalle demonstrates the power and versatility of AI in generating diverse and unique images. Here are some examples of images generated by Dalle. A three-legged elephant holding an ice cream cone. A toaster with a face. A dog playing guitar. Dalle works by encoding textual descriptions into a latent space and then using that latent code to generate an image. It uses a transformer architecture similar to GPT-3 to process the textual description and generate a latent code. This latent code is then passed through a generator network to produce the final image. The model is trained on a large data set of images and textual descriptions, allowing it to learn the relationships between words and images. This allows Dalle to generate new, never-before-seen images that match the description provided to it. It's important to note that Dalle generates images from textual descriptions, not from pre-existing images. This means it's capable of creating truly novel and imaginative images, limited only by the descriptions it's given. Jasper is a parallel training technique for large language models developed by OpenAI. The name Jasper stands for Just Another Sparse Parallel Execution Research. Jasper is designed to train large models more efficiently, using less memory and computational resources than traditional training methods. Large language models, such as GPT-3, require a significant amount of computational power to train. Jasper addresses this issue by using a sparsity-based parallel training technique that divides the model's parameters into smaller, more manageable chunks. This allows the training process to be parallelized and distributed across multiple GPUs or machines, reducing the amount of memory and computation required. By utilizing Jasper, OpenAI is able to train large models, such as Dalle, in a more efficient and cost-effective manner, enabling them to push the boundaries of what's possible in the field of AI. Traditional training methods for large language models typically use dense, full matrix operations, which require a significant amount of memory and computation to train. This can lead to limitations in terms of the size of models that can be trained and the length of time it takes to train them. Jasper, on the other hand, uses a sparsity-based parallel training technique that divides the model's parameters into smaller, more manageable chunks. This allows the training process to be parallelized and distributed across multiple GPUs or machines, reducing the amount of memory and computation required. Compared to traditional training methods, Jasper is more efficient in several ways. Memory efficiency. Jasper requires less memory to store the model's parameters, as it only needs to store the non-zero elements of the parameters. This allows for larger models to be trained and reduces the amount of memory required during the training process. Computational efficiency. Jasper parallelizes the training process, allowing it to be distributed across multiple GPUs or machines. This reduces the amount of computation required to train the model and speeds up the training process. Scalability. Jasper can be easily scaled up or down depending on the number of GPUs or machines available, making it easier to train models of different sizes. Dynamic computation. Jasper allows for dynamic computation, where only the non-zero elements of the model's parameters are computed, reducing the amount of computation required. Flexibility. Jasper is flexible and can be used with a wide range of deep learning models, making it a versatile training technique. Performance. Jasper has been shown to produce models with comparable or improved performance compared to traditional training methods, demonstrating its effectiveness. Cost savings. By reducing the amount of memory and computation required to train large models, Jasper can lead to significant cost savings for organizations and researchers. Improved resource utilization. Jasper can better utilize available computational resources, such as GPUs, allowing for larger models to be trained with the same amount of resources as smaller models trained using traditional methods. In summary, Jasper provides a more efficient and scalable way to train large language models, enabling researchers to push the boundaries of what's possible in the field of AI. Jasper offers several key benefits over traditional training methods for large language models. Reduced training time. Jasper parallelizes the training process, allowing it to be distributed across multiple GPUs or machines, reducing the amount of memory and computation required. This results in faster training times and allows for larger models to be trained more quickly. Lower memory usage. Jasper uses a sparsity-based parallel training technique that only stores the non-zero elements of the model's parameters, reducing the amount of memory required to train the model. This allows larger models to be trained and reduces the amount of memory required during the training process. Improved accuracy. Jasper has been shown to produce models with comparable or improved accuracy compared to traditional training methods, demonstrating its effectiveness. Cost savings. By reducing the amount of memory and computation required to train large models, Jasper can lead to significant cost savings for organizations and researchers. OpenAI's Dalle and Jasper have the potential to be used in a variety of real-world applications, including image synthesis. Dalle can be used to generate images from textual descriptions, making it a powerful tool for image synthesis in areas such as product design, advertising, and entertainment. For example, Dalle could be used to generate realistic product images or designs based on written descriptions. Language understanding. Jasper can be used to train large language models for tasks such as language translation, text generation, and sentiment analysis. This can improve the accuracy and performance of these models, making them more useful for real-world applications. Creative writing. Jasper can be used to train large language models for creative writing tasks, such as generating poetry, short stories, or even screenplays. The improved accuracy and performance of these models can lead to more creative and realistic output, making them useful for a variety of creative applications. Virtual assistants. Dalle and Jasper can be used to train virtual assistants to better understand and respond to human language. This can lead to more accurate and effective virtual assistants, improving the user experience and making them more useful for real-world applications. Medical imaging. Dalle can be used to generate medical images, such as CT scans or X-rays, from textual descriptions. This could be useful for training medical professionals or for creating realistic images for simulations or virtual reality training. Personalized product recommendations. Jasper can be used to train language models for personalizing product recommendations. This could be used to make personalized product recommendations to customers based on their past purchases, search history, and other factors. The improved accuracy and performance of these models can lead to more accurate and relevant recommendations, making them useful for a variety of e-commerce applications. In conclusion, OpenAI's Dalle and Jasper represent significant advancements in the field of AI and have the potential to revolutionize a variety of real-world applications. Dalle's ability to generate images from textual descriptions make it a powerful tool for image synthesis, while Jasper's efficient parallel training technique makes it a valuable tool for training large language models for tasks such as language understanding, creative writing, and personalized product recommendations. The potential applications for these technologies are numerous, and it will be exciting to see how they are used in the coming years to improve and simplify our lives. I hope this video is productive for you all. Thank you for watching the video. Please subscribe to the channel for more videos.